good evening to all of you. Yes, can you hear me? Hello guys, good evening to all of you. Yes, can you hear me?
Good evening, sir. Yes, sir. Yes.
Yeah. So thank you for your response. Yes, so let us start our session. See, yesterday, just discuss 1 second. Yesterday, discussed about only introduction, like about myself, next about course plan, and all this we discussed. Okay. Now today we'll start actual topic. Okay. So first starting with big data topic. Okay. Yes, in Hadoop, first topic is big data. Next about HDFS. Next MapReduce, like that one by one discuss. Okay. So first starting with what is Hadoop. Of course, yesterday we have discussed. Yes, little bit I'm repeating yesterday topic. After finishing yesterday topic, we'll go to new topic here. So what is Hadoop? First question, what is Hadoop? Yes, how to answer this? For this answer. So what is Hadoop? Hadoop is an open source. Hadoop is an open source to store and process, big data, to store and process big data. Hadoop is an open source. Hadoop is an open source to store and process big data. Hadoop is an open source. Hadoop is an open source to store and process big data. That point is clear, right? Now here, so why named as Hadoop? The topic later we'll discuss. That Hadoop history later we'll see. Why named as Hadoop? The topic later. Next here, open source. So what is open source here? So Hadoop is an open source. Now question is, what is open source? What is open source? Next question is, what is open source? See, there are two things here. Freeware, second one, open source. Freeware, next open source. Freeware and open source. So what is freeware? What is open source? Both looks like a same here, but exactly not same here. Both are not same. Both are not same. So what is freeware? Freeware means, yes, it can be downloaded. Freeware, yes, it can be downloaded and used at free of cost. And used at free of cost. Free of cost. Okay, it can be downloaded. Yes, it can be downloaded and used at free of cost. It's a freeware, but it cannot be modified. But it cannot be modified. It cannot be modified. It cannot be modified. It cannot be modified. Okay, but it cannot be modified. Say freeware. Next, what is open source? Open source. What is open source? See, open source. It can be downloaded. It can be downloaded, including, yes, including source codes. It can be downloaded including source codes. Okay, open source. It can be downloaded including source codes. Source codes. What is source codes? Here Hadoop. Hadoop developed in Java. Hadoop developed in Java. Yes, all the Java programs you can download it. Hadoop developed in Java. All the Java programs you can download it and you can modify. Okay, all that, it's nothing but source code. The Java programs nothing but source code here. It can be downloaded including source codes and also can be modified and also can be modified and also can be modified and also can be modified. So this is open source. Okay, so the meaning of open source is this here. Right? Okay. Yes. Next. Yes, open source framework. Open source framework. Yes, open source framework. Hadoop is an open source framework. What is framework? Let us see. Yes, what is Hadoop? Hadoop is an open source framework to store and process big data. To store and process big data. To store and process big data. Okay, right? Yes. Next question. Yes. What is framework? Next, what is framework? Next question is what is framework? So next question is what is framework here? So how to answer this? Framework, it's ready-made one. Ready to use. Framework means it's a ready-made one. So framework, yes, it is a ready-made one. Ready-made one, ready to use. And ready to use. Ready to use here. No coding, nothing. Without any coding, you can use framework directly here. Framework, predefined, all the predefined classes. Just everything, all are predefined class will be here. The predefined classes you can use here. Okay, without writing any codes, we can develop the applications here. Ready-made one, ready to use. So this is meaning of framework. Okay. Next, big data. See, Hadoop is an open source framework. So what is open source? That is clear. Next, what is framework? Also clear. Next, to store and process big data. Now, what is big data? Let us see about big data. So what is big data? Next question is, what is big data? So next question is, what is big data? Next question is big data. So what is big data? Let us see. 1 second. Yes, all these Word documents. Yes, I'll share you what I discussed that Word documents. I'll save into Word documents. Let me take Word documents. Blank documents. Yes, here. That's clear. So this document I'll be sharing you. Save. More options. Save as, browse. D drive. Hadoop. Yes, let me create separate folder for our batch. 8 p.m. 9:30 a.m. Yes, new folder. Yes. Hadoop. 9:15 p.m. Okay. This Hadoop introduction. Yes, I'll share this document in WhatsApp group. Yes, I'm creating WhatsApp for you guys. Yes. Yes, I'll create WhatsApp group. Yes. In WhatsApp group, I'll share daily documents. Okay. Some documents, big one, then I'll share through the email. Yes, some cases I should share through the Google Drive. So big documents and yes, some zip files I should share through the Google Drive every day. Okay. Yes. Now what is Hadoop? Okay. Next, what is open source? Okay, these things. What is framework? Okay. Next, what is big data? Let us see what is big data. Our topic is big data. What is big data? How to answer this? Yes, what is big data? For example, here, let us take some company. There is a company. Yeah, there is a company with 100 TB data storage space. Yes. Yes, a company with 100 terabytes of data storage space. Yes, this is a company with yes 100 TB data storage capacity. Data storage capacity right? 100 TB database server. Database server. This is yes. This capacity of the server is 100 TB. Capacity of this is 100 TB. 100 TB database server. This is yes that capacity 100 TB. Right? Okay. Suppose this company started just 5 years ago. Suppose 2015 company started. 2015 started company here. Started, right? So first year, less number of transactions. Because startup company, less business, right? Startup company, less business. 2015, some transactions. For all the transactions, generating some data. Generating data into this database, right? Okay, right? Next year, 2016, data generating 2017. Yes, in long run business increasing. Yes, next with the quality service, more business, more and more business getting rich. If more business, if they are doing more business, more transactions and more data. More data generating instead of database server. Generating the database server, right? Next 2018, yes, 2019 like this. 2019 like this data inside database, right? Okay. Suppose reach to 2020. When reached to 2020 here, so database server filled. Database 100 TB filled over 100 TB filled. Still data is there. That means company facing big data problem. So what are data generating? What are data generating? If the data is more than the capacity, what's the capacity? Only 100 TB, but data is more than the capacity of server. Okay, so if data is more than capacity of server, that is called as big data. Okay, so beyond of storage limit, data generating beyond the storage limit. What is storage limit? Only 100 TB, but data is more than 100 TB here. Means now company facing big data problem. This is called as big data. But again, so any data which is beyond of storage limits, that is called as big data. Yes, let me explain one more example here. Suppose your laptop with 1 TB storage. 1 TB storage, right? Your laptop with 1 TB storage. Suppose your laptop maybe purchased some 3 or 4 years back. So 2017 purchased. Yes, in 2017 generating some data. Next 2018, maybe your office work, maybe your personal files, personal data, something like this. Some data generating. Maybe downloading movies. Okay. Yes, maybe your family function, videos or audio, something like this. Maybe some photos. All the data generating, right? Continuous data generating. 2018, suppose 2019, suppose 2020, suppose reached 2020, suppose in this year your disk filled, that 1 TB disk filled. 1 TB disk filled. You can't use, right? 1 TB disk filled. Yes, still data is there. That means you facing big data problem. Yeah, this case you facing big data problem, right? Your data is more than the capacity for 1 TB space. Yes, your capacity only 1 TB space. Your system capacity only 1 TB space. But data is more than 1 TB. Means you facing big data. Yes, 100 TB this case, company facing big data problem. 1 TB, your case, you facing big data problem here. So this is nothing but big data, called as big data. So any data, yes, maybe 1 GB data or 2 GB data, maybe 100 GB data, maybe terabytes of data. Any data which is beyond of storage limits, beyond the storage limits called as big data. Correct? So any amount of data, yes, which is beyond of storage limits, is called as big data. Beyond of storage limit is called as big data. That's it. So any amount of data which is beyond of storage limit called as big data. That okay? Yes, this big data, yes, big data not able to process by traditional systems, traditional databases. If generating big data, traditional systems not in a position to process the data. See, I'll tell you one more example here. See, 1 byte equal to 8 bits, right? 1 byte equal to 8 bits. Okay. Next, 1 KB equal to 1024 bytes. 1 KB equal to 1024 bytes. Next, after KB, next MB. 1 MB equal to 1024 KBs. Yes, after MB, 1 MB. After 1 MB, next GB. 1 GB is equal to kilobytes, megabytes, gigabytes, 1024 MB. Yes, after gigabytes, next terabytes. 1 terabyte equal to 1024 gigabytes. Next petabytes. 1 petabyte equal to 1024 terabytes. Next, after petabytes, next exabytes. 1 exabyte equal to 1024 petabytes. Next, zettabytes. 1 zettabyte equal to 1024 exabyte like this. Here this is. Yes, KB 10 to the power of 3, KB 10 to the power of 3, next 10 to the power of 6, 10 to the power of 9, 10 to the power of 12, 15, 18, and 21. Right? Yes, in this here up to GBs comes under small data. Up to GBs, it's a small data. This is small data. This is small data. See, terabytes to zettabytes. Terabytes to zettabytes comes under big data. This is big data range. Big data range, right? It's a big data range. See, traditional databases. See, traditional systems like traditional databases. Traditional database servers like Oracle, traditional database servers like Oracle database server, yes, maybe MySQL database server, yes, maybe Microsoft SQL server, MS SQL servers, yes, these servers are not in a position to handle this range of data. Terabytes can't handle. These servers, yes, terabytes, petabytes, this range can't handle. Terabytes can handle, but petabytes, exabyte can't handle here. Okay, so this kind of this data is not a big data here. This data is unable to store and process by the traditional systems. Data which is unable to store and process by traditional systems is a big data here. So big data. So traditional systems are not in a position to process that much of data here. 1 terabyte of data can't here. 1 terabyte of data, okay. Suppose 100 terabytes of data, no. Yes, Oracle database can't process 100 terabytes of data, 50 terabytes of data. 10 TB, okay. It can process 10 TB data, no problem. But 100 terabytes can't process. It can't process 100 terabytes of data. 1 petabyte data can't process. So these traditional systems can't process that much of data. That is called big data. Okay, right? So what is big data? First question, what is big data? So what is big data means? Simply answer here. What is big data? Any amount of data which is beyond of storage limit. First point, any amount of data which is beyond of storage limit is called as big data. Right? Okay. So big data means really it's a big one. See, big data is a really big one. Really it's a big one. Really it's a big one. It's a big one. Big one. Yes, which is, yes, really it's a big one. Yes, which is unable to store and processed by traditional systems. Traditional systems are traditional databases. Traditional systems. Okay, so data which is unable to store and process traditional systems comes on big data here. The data which is unable to store and process by the traditional systems called as big data. So this is what is big data. Simple definition, just introduction. Okay, this is just big data introduction. Okay, right? Yes. Now let us see what are the different sources of big data. Yes, see, we are using many applications every day. We are using many applications, right? There are different kind of applications to generating different kind of data here. Many applications generating lot of data every day. So what are the different sources of big data? Let us see different sources, some examples, some big data examples. Let us see about some big data examples. So what are the sources of big data here? Different sources of big data. Yes, sources of big data. So what are the sources of big data here? So different sources of big data. First one, best example, historical data. Historical data comes in big data. Historical data is a big data here. Historical data means 2 years of data, 3 years of data, 5 years of data, 10 years of data. That all the data comes in the big data. 10 years of data is not easy, right? 1 year data can maintain, no problem. 2 years data, no problem. 3 years data, but 10 years of data maintaining is not easy. That historical data, it comes in big data here. Yes, maybe 10 years of data, it's a big data. 1 year data means small data. Okay, right? 1 second. See, here, historical data. Next, one more thing, they say transaction data. There are two things here. First one, historical data. Historical data. Historical data. Next is transaction data. Historical data, then transaction data. Historical data, transaction data. Yes, Hadoop is for the historical data. Yes, historical data. Next is transaction data here. So what is historical data? What is transaction data? Hadoop is always for historical data, not for transaction data. Okay. So what is historical data? So what is historical data here? Historical data means it's a old data. Just it's a old data. Okay, old data. Maybe last 1 year, last 2 years, or last 3 years, last 5 years. All the old data comes in historical data. So once year closed, once financial year closed, the data comes under historical data. So year closing, once year closed, it's a historical data. That historical data may be 1 year data, 2 years data, or 3 years of data, 4 years or 5, 10 years of data. That is called big data. Next, what is transactional data here? Transactional is a live data. Live data. Okay, live data means it's a day-to-day data here, daily data here. So it's a daily data. It's a daily data here. It's a daily data, day-to-day. Yes, it's live data here. For example, I'll tell you some transaction data. I'll tell you one transaction here. Yes, transaction data anytime modifying here, updating transaction data, but historical data cannot be modified here. Historical data cannot be modified here. So here old data, the next it cannot be modified. It cannot be modified. Historical data cannot be modified here. See, once year closed, the data comes in historical data. Okay. If you try to modify that old data, what happens here? Your balance sheet get affected, right? That should not be modified. That old data cannot be modified. We can't modify. History, we can't modify that. Okay. Now transactional data, it's live data. It can be modified anytime here. Yes, it can be. It can be. It can be modified anytime here. It can be modified anytime here. At any time here. It can be modified at any time. At any time. For example, here, let us take some Flipkart example. Flipkart order placed. Suppose initially here, Flipkart. Suppose purchasing some item. Purchasing some item, right? When you purchasing item here, first step, Flipkart, first add to cart. Once you select that option, yes, your that order open, status is open. Started transaction here, open. Status is over. That record generating here. See, log in into Flipkart with your account here. Log in into Flipkart with your account. Now placing order. Suppose add item to cart. First item, yes, cart. When cart is open here, status is open. Next, adding item. Next item. After adding all the items here, next, submit for bill. Submitting for bill, right? Yes, so next status is submit. Submitted for bill, right? Submitted for bill. After submitting here, it shows one bill, right? Maybe huge. If you feel more than your capacity, you will cancel. Suppose if it is okay, then confirm. Then confirm, right? If it is okay, confirm your order. So what is status? Initially opened, submitted, and confirmed. Next, confirm, right? Once it confirmed here, once confirmed, that Flipkart has to accept your order. Flipkart has to accept your order here. So order accepted. So next is status is order accepted. Order accepted. Okay, in Flipkart transaction like this. Open, yes, submitted, confirmed, accepted. After accepting here, next packed. Status is packed. After packed here, next is what? Shipped. Shipped. Yes, after shipping here, next status is delivered. Delivered. Delivered to client location. After delivered to client location, client will inspect the item. After inspecting item here, accepting. Yes, accepted order here. Accepted or record, rejected. Accepted. Once accepted here, received amount here. Yes, received. Payment received here. So payment received. Payment received. Payment received, right? Payment received. Once payment received, next what here? Order closed. Order closed. So this is status, right? Yes, open. Open transaction maybe first day of September. Okay, first day of September closed maybe 10th September means between these 10 days. Yes, between open close 10 days. So within these 10 days that status changing, right? Now this is called transaction data. Transaction data can be modified at any time here. Okay, so initial status open, submitted, confirm the record is being modified 10 days, modifying. Sometimes for some record may be modifying for 1 year. Started Jan months, maybe ending at December months. That may be ending at maybe taking 1 year or 6 months, 3 months like this. That is nothing but transactional data. The data can be modified anytime here. Transaction data can be modified anytime. This is called transaction, it's live data. Suppose year completed, year end. Yes, December 31st. Yes, US December 31st, in India 31st March. Suppose 31st March, year completed, year closed. Once year closed, the data comes in the historical data. Once year closed, up to that whatever transaction, all the transactions comes in historical data. Yes, historical data. When come to historical data here, maybe 1 year data or 2 years data, maybe 3 years, maybe 4 years or 5 years like this. Yes, if it is historical data, it's a big data. Suppose transaction data is less amount of data. Traditional systems can handle transaction data, no problem. Traditional systems can handle transaction data, but historical data, no cannot. Traditional systems cannot handle historical 10 years of data handling here. No. So traditional systems can handle only 1 or 2 years data, not more than that. So this historical data comes in big data. This is one of the examples of big data. Historical data. Next, one more example here. One more example. Big data examples. One more example. Suppose black box data. What is black box? Any idea? Anyone idea of what is black box?
The flight status recorded.
Right, you are right. Yes, black box data, black box. Yes, black box is a data recorder. Data recorder in aircrafts. Aircraft, right? Black box. It's a data recorder. Just it's a data recorder. Yes, in aircrafts. Yeah, this data record generates huge amount of data every day. Lot of data. Yes, black box recording everything here. Like yes, conversation between crew members. This is a crew, flight crew, right? Flight crew members. Yes, flight crew members conversation. That conversation recording by the black box. Crew means staff, the flight staff. Okay, like captain, main pilot. Yes, every flight minimum two pilots. Two pilots. Main pilot is a captain. Main pilot is a captain. Next, second pilot. Next, mechanical engineer. Yes, this is the mechanical engineers are presenting the flight here. Okay, so main pilot is the captain. Next, second pilot, mechanical engineer. Next, air hostess, and then supervisor for all these crew members. This supervisor. This whole is a crew. Yes, that crew. What are the conversation between crew members recording by the black box? Okay, not only conversation you get information about the flight information, flight current information means what's the flight information, like what's the altitude of the flight currently flying here. Altitude means height. What's the height? Altitude. Next, what's the direction? In which direction flight is traveling? Okay, Next, like longitudes and latitudes and all the positions here. Next, what's a fuel capacity? What's a current fuel? That information. Next, weather information. Yes, weather information, temperature information, all that information here maintained by the black box. Not only that here, capturing something like suppose flight traveling across some mountains, it will capture that mountains also. Traveling across sea, it will capture that also. Maybe villages and towns. Yes, it will capture everything. All the images continuously capturing all that images. Right, okay. Not only this, sometimes conversation with ATC here. There's a conversation, flight captain conversation with ATC, air traffic controlling system. ATC, air traffic controlling system. Every airport there's ATC. In every airport there's the ATC. Before landing to airport, that captain should talk to ATC. Okay. So once gets the permission from the ATC, they can land in the airport. Otherwise, they cannot. ATC should give the route clearance. Without giving clearance, should not be landed. Yeah, recently happened in Chennai, with Chennai or Kerala somewhere. Without giving route clearance, landed into airports. Some accident, minor accident, of course, it's a minor accident was happened here. Without clearance, without giving clearance, landed. Okay. Simply accident was happened here. Yes, ATC's compulsory should give the clearance. Once route clearance given here, they can land at airport. Otherwise, should not be landed. Okay. Yes, all this information that what are the conversation between captain and ATC that will be recorded in black box. Okay. Yes, this black box. Yes, nothing effect on black box here. Suppose some accidents, maybe fire attacking. Yes, nothing will affect on black box. Suppose sinking into some sea, nothing will affect on black box. Okay. Yes, no chance of fire attacking, no chance of water attacking, nothing will attack here. It's a safe always. Okay. Now this black box generates 20 GB data per hour. 20 GB data per hour generates here. This one generates 20 GB per hour. Next, in a travel, how much data generates? In a per travel, how much data generates? For example, here, Hyderabad to Chicago. Yes, every year we are traveling to on-site. Our on-site work here, Hyderabad to Chicago. Yeah, this is 36 hours time, almost 36 hours. Will be taken for 36 hours. Yes, to and fro, going there, coming back, 36, 72 hours. Delay and all, yes, around 80 hours. Yes, around 80 hours will be taken here. 80 hours travel here. For travel, 80 hours. 80 hours. 80 hours, right? Means almost 3 days. 80 hours. So if it is 80 hours, how much data generates here? 80 hours means 80 multiplied by 20 GB data is equal to how much here? 1600 GB data generates. For travel, 1600 GB generates. 1600 GB is nothing but say 1.6 TB, right? This is equal to, yes, around 1.6 TB terabytes. See, 1 terabyte equal to 1024 divided by 1000, right? Divided by 1000 means 1.6 TB travel. Next, in a month, maybe 10 travels. In a month, maybe 10 travels. So 10 travels, how much here? 10 multiplied by 1.6. 10 multiplied by 1.6 equal to 16 terabytes. Yes, one flight generating 16 terabytes of data in a month here. 16 terabytes of data. Like this, many flights. So 1 month. So for 12 months, yearly, 12 multiplied by 16 here is equal to 12 multiplied by 16 is equal to 192 terabytes of data. 192 terabytes of data, right? This much of terabytes of data generating. Yes, it's a one flight. Let us take British Airways. British Airways is a, yes, very large scale one. Yes, many flights. They have many flights. Worldwide famous British Airways here. Having many number of flights. Yes, more than 200 flights they are running here. more than 200 files they are maintaining here. So 200 files multiplied by, so 192 means, yes, around 200 into 200. Yes, 2 into 2, 4, 0, 0, 0, 0 like this. Yeah, 4 zeros around this is. So this value is equal to 40 petabytes of data. Yes, divided by 1000 means converts in petabytes. Now yearly generating 40 petabytes of data. Where to store all this data? The data is somewhere, right? It's not easy. 40 petabytes of data. 40 petabytes of data. How many computers required here? Yes, how much space required in the disk here? Yes, how many computers in data center required here? Yes, many number of computers, right? Very big data center required. Okay, right? Yeah, this kind of data is nothing but big data. So this is one of the source of big data here. Black box data here. Historical data, black box data. Yes, let us see one more example here. One more example is stock exchange data. One more example. Yes, stock exchange. Stock exchange data. Yes, stock exchange. Every lot of trading. For example, New York Stock Exchange, NYSE. Next, Bombay Stock Exchange, BSE. These stock exchange generating a lot of data every day. Yes, New York Stock Exchange, very big one. Is lot of trading every day. Yes, many companies listed here. Lot of trading every day here. Yes, New York Stock Exchange at, yes, New York Times Square. Yes, New York Times Square is very famous. It's very famous. Almost, yes, every company, top 10,000 companies or top 5,000 companies will have office compulsory at New York Times. It's a prestigious for the companies here. So top 1,000 companies compulsory guarantee there's a office at the New York Times Square. Very famous. Okay, New York Times Square here, very famous. Okay, every company will have their office. Almost to top 1,000 companies will have office there. It's a prestigious for them. Okay. Yes, this stock exchange will do a lot of trading every day. Lot of trading every day. So every day daily information they should maintain this. Okay. Suppose for example here I want to purchase some shares. How to purchase? Yes. Share how to decide whether to purchase or not. Which is the best one here? By considering history, right? What's the share value today? Yesterday, maybe last 3 days, last 1 month. What is happening daily? What is happening last 1 month? Is it growing or increasing or decreasing share value? Checking all the right. Maybe 2 years history, 3 years history, right? By considering that, by considering history, we'll purchase the shares. Yes, here generally shares here suddenly share value increase, that is not believable here. So gradually share value increasing, it's a believable. Suddenly share value raised means something manipulation was done. Okay, so our share value gradually increasing, yes, we can believe, we can purchase it, right? Yes, who will provide all that information here? Stock exchange. Stock exchange will provide all that information here. Okay, someone may be asking you 5 years of information here or 6 years. They should provide this. So every share information, customers information, and companies information, minute to minute information they have to, yes, minute to minute information they should share it here. Okay, suppose started, yes, share market started. What's the open? First, initially, what's the value? Next minute, what? Minute to minute, they have to maintain all this data here. It's not easy. Minute to minute data is not easy here. Okay. So like this, generating big data. So 5 years of data, 10 years of data like this. This is one more example of this stock exchange data. Right, okay. Next, one more example, banking data. One more example, banking data. Banking data. Banking data. Yes, customers are asking for, yes, that their statement, right? Maybe 1 year statement, so 2 years or 3 years, maybe 10 years also. Yes, someone is asking for 10 years of statement. So banks have to maintain 10 years of data, right? Very big data. For example, here, some scam was happened recently here. Yes, like for example, Nirav Modi. Let us take him here. Nirav Modi. He has opened account in 2007 in Punjab National Bank. Punjab National Bank, right? Now CBI into the field. Now they are started investigation, right? Now CBI will take all the statements from the beginning, right? Yes, CBI will ask the statement for this, right? CBI has taken all the statements 2007 to this year, means 13 years of statement. CBI has taken 13 years of statement, right? So 13 years of data they have to maintain, means a big data. Not only 1 year, 2 years, 13 years or 20 years. Not only one customer, many customers. All the customers' information. Next, different type of transactions like maybe savings accounts. Next, maybe current accounts, maybe fixed deposits. Yes, maybe insurance, something like this. Various kind of housing loans. All the data, right? How much data generating here? Lot of data every day. They should maintain a lot of data. Very big data center required for them. So that is what big data here. Example of big data. Again, yes, next. One more example, power grid data. Power grid, power supply, power grid data. Yes. So every month, how much power is supplying here? That information has to maintain this. Yes, customers, consumers, like yes, like domestic customers, industrial customers, maybe commercial, different kind of customers here. Their consumption, power consumption, they should maintain this. Power grid. Grid is using for distribution, like water grid, power grid. Grid means using for storage. Grid is for storage and distribution. Grid, storage and distribution. That grid has to maintain all that information, right? If that information required compulsory care. Yes, suppose next month what's the power demand? How to predict? Prediction power, predict demand prediction here. If that state government has to predict how much demand required in next month here, how they can predict here the demands based on history. Last year October month what's the power demands? Previous year October month what's the power demands? Based on that, yes, based on that they can analyze. So power prediction here for this purpose they should mean all the data, right? Demand, how much demand in the field they should estimate, otherwise government will fail. Right, okay, so power grid data, this also comes on this. Like this, many examples you can discuss. Many examples. Okay, like one more important one. I forgot it here. Social network sites. Most important social network sites. Social network sites. Social network sites. Like Facebook, Google search engine, yes, Gmail server, Gmail, yes, Gmails. Next, like WhatsApp, yes, like WhatsApp, all the network sites, right? Yes, social network sites, WhatsApp. Next, YouTube, yes, YouTube. Okay, Twitter. Next, yes, LinkedIn, like this, right? Many network sites are social network sites. Yeah, they are generating a lot of data every day. Lot of data generating every day. There are examples here. Next, online shopping. Amazon. Yes, online shopping. Yes, Amazon doing lot of business. See, Amazon not only online shopping here. Amazon has the lot of business like cloud. Amazon has the cloud computing. Yes, we are going to discuss same thing here. Amazon cloud in Hadoop. I'll be explaining cloud, how to work with the cloud here. AWS. Hadoop on AWS. That also will be discussing. Okay, so how to set up Hadoop in AWS environment, cloud environment, Hadoop setup also we're going to discuss. Okay, yes, online shopping here, maybe Amazon or Flipkart, something like this. Okay, next medical data. Medical data, yes, insurance data. Suppose insurance data. Yes, long-term insurance, right? Maybe 30 years insurance, some policies. 15 years, 20 years. So vehicle incidents, 30 years, 40 years. So what truck incidents, maybe 30 years, 40 years. That incidents, right? All the data has to maintain this is. But okay, next, transport data. Transport data. Transport data. Suppose Indian Railways. Indian Railways. Many number of passengers traveling every day, right? All the passenger information they have to maintain this is. Not only 1 year data, all the years of data here, maybe 10 years or 20 years, all the data they have to maintain this is. Yes, all these are big data examples. These are big data examples. Yes, that is sources. Yes, just the only introduction. Going forward, we'll see. Yes, what is exactly big data? Practically, I'll show that how that big data behaves, how to analyze the big data, how to store, how to process, and all the things we'll discuss practically. So these are the different sources of big data. Right? Okay. So what is Hadoop? So what is big data? Next, what are the different sources of big data? These points were clear. Clear, okay? Yes, 1 second. For all the topics, I have prepared document also. Document is available. Yes, you can follow the document here. Yes, running notes is not necessary here. Running notes is not necessary. You can follow document here. Yes, Hadoop big data documents. Yeah, this is updated document. So these are document here. Yes, what is big data? The definition, big data definition. See, any amount of data which is beyond of storage capacity, big data, like this 1 bytes, kilobytes, megabytes, gigabytes, terabytes, petabytes, whatever we discussed, everything prepared in document here. Guess what comes in big data here? Historical data, black box data, social media data, stock exchange data, power grid data, transport data, search engine data, other examples, banking data, online shopping, all this comes in big data. Right, okay? Yes. So this is just a big data introduction. Okay, fine. Yes, next here, see big data. See traditional, all the traditional systems like traditional database servers, like a Oracle database, Microsoft SQL Server, MySQL, like this, there are different traditional database servers. These all the traditional database servers are not in a position to process, store and process big data here. They can't handle. Big data means terabytes. Big data comes under terabytes, zettabytes, this range. Big data range. This is big data range. Yes, traditional systems cannot handle. Yes, can't handle this kind of data here, right? There are a lot of challenges. With big data, a lot of challenges. Traditional systems can't meet the challenges here. Challenges. Yes, let us see what are the challenges from the big data here. Yes, big data challenges. There are some challenges from the big data here. Traditional systems are not in a position to face all the big data challenges. Let us see. What are the big data challenges? Big data challenges. Big data challenges. Okay. First one, what is main challenge big data? Storage. Main problem is what? Storage problem. Big data challenge. Main problem, data storage. Main problem, data storage. Main problem here, data storage. Main problem here, data storage. Okay. Data storage. Next, data processing. Big data processing is not easy. So what 10 GB data is not an issue, can process. 20 GB data can process, but 1 TB data, yes, Oracle engine can't process that much of data here. Data processing here, engine, that maybe Oracle database engine, MySQL engine, those engines are not in a position to process big amount of data. That engines will stuck sometimes here, maybe sometimes hanging. Okay, so there are many challenges with big data here. Yes, we'll see some important challenges. Yes, I'll tell you some important challenges here. Data storage, main challenge here, data storage. Next, one data processing here. Data processing, data storage, data processing. Next, with big data here, high-end hardware required. High-end means, right? High-end hardware means costly hardware. Yes, more infrastructure, expensive. With big data, more data means more as high-end hardware required. Means high-end disk required. Maybe 100 TB disk, maybe 200 TB disk like this. Next, high processor required here. To process big data, high-end processor required. Okay. So high-end hardware. Yes, with big data, high-end hardware required. Next, with big data, sometimes chance of generating very large files. Very large files will generate here. Yes, traditional systems can't handle large files. Suppose Linux space cannot handle large file here. Windows space cannot and large file here. Large files. Windows, Linux, they can handle only maximum 50 GB data file. So our data more than 50 GB can't handle. Data more than 50 GB generating here. Yes, that much of file can't handle. Maximum size of the file that can be created in Linux is only 50 GB, not more than that. Yes, I'll show that also. Going forward, I'll explain it. So what's the maximum size of the file that can be created in Linux base? Practically, I'll prove that. Okay. So very large files. So challenge is very large files. Next, backup. Yes, big data backup taking daily is not easy. Backup and recovery. Suppose some server failed. Recovery task. It's not easy. Okay, it's risky task. Okay, right? Yes, next. Disaster management. Disaster. One more important one here. Disaster management. Management means like natural disasters. Natural disasters like maybe earthquakes, sometimes maybe heavy floods, maybe tidal waves getting our short circuits, like this natural disasters. These are the main big data challenges. Apart from this, other challenges are there. Those things later I will discuss. These are the main challenges. Okay. Now, traditional systems are not in a position to face all the challenges. Traditional systems are failing to face all the challenges. Traditional systems can't handle all the challenges. For this, which is right technology here? Yes. Which is the right one to handle all this here? Hadoop. Yes, provides Hadoop provides best solution. Hadoop provides best solution. So Hadoop provides best solution to handle all the above challenges, all the above challenges, all the above challenges, all the above challenges, all the above challenges. Yes, we'll see one by one. One by one. Traditional systems versus Hadoop here. See, traditional systems versus Hadoop. We should discuss traditional systems versus Hadoop here. Hadoop. See, data storage. How traditional system will maintain data here? Will store and maintain data. Next, Hadoop. Same data in Hadoop. How this will maintain here? Storage. Storage system in the traditional systems and Hadoop. Storage. Traditional systems versus Hadoop. Very interesting topic. These things here. Okay. Very interesting topic. This is. Yes, data storage. How in traditional system, then how in Hadoop. Traditional system following some vertical scaling, Hadoop following some horizontal scaling. So what is vertical, what is horizontal? Tomorrow we'll discuss. Tomorrow we'll discuss that here. Next, data processing here. Yes, how data processing traditional system. Yes, how the data processing Hadoop here. Data processing traditional system and Hadoop here. So all the challenges, traditional systems versus Hadoop here. Okay. So data storage, data processing, high-end hardware in traditional systems and Hadoop here. Next, very large files, traditional systems versus Hadoop here. All the challenges will compare this to here, between this to here. Traditional systems versus Hadoop here. This is the topic. So this topic tomorrow. Tomorrow we'll be discussing about this topic here. Yes, somewhat interesting topic this is. Data processing, data storage in Hadoop here, data storage in traditional systems. Data processing by the traditional systems, data processing by the Hadoop. How Hadoop can process big data. Yes, how Hadoop can store big data. These are the concepts. Next, with big data, with Hadoop, high-end hardware not required. We can go with low-end hardware here. How it is possible here. Next, very large file. How Hadoop can handle very large file. Next, backup. Yes, with the Hadoop backup, manually not required. Hadoop takes care of backup here. How Hadoop takes care of backup? Automatically taking backup here. How Hadoop can take backup automatically? Next, recovery process. Suppose any server failed, that will be recovered automatically here. Yes, Hadoop engine will recover server automatically here. Traditional systems, manual recovery required here. In traditional systems, manual backup and manual recovery required here. Disaster management, this is also manual here. In traditional systems, these are manually, but in Hadoop, automatically handling. Hadoop will handle automatically. Yeah, this topic tomorrow we'll discuss. See, this data storage, tomorrow completely focus on data storage. Yes, minimum 1.5 hour topic, the data storage. Okay, data processing, one more session. These two will be taken for 2 sessions. So next 2 sessions, data storage and data processing, like distributed data storage, distributed data processing, those concepts tomorrow topic. Okay, next, these are simple. So 2 sessions enough to finish all these challenges. After finishing this challenge here, overview finishing here. After finishing this overview, we'll go to Hadoop setup. Hadoop setup. After Hadoop setup, we'll discuss Hadoop internal architecture. Next, start working with Hadoop here. Practically, we are going to set up. Okay. See, I'm not explaining an existing setup. I will make you set up here from the scratch. From the scratch, I will make you set up the Hadoop here. You have to set up on your own. All the configurations, everything you have to prepare and you have to set up here. I will make you to set up. Okay. Generally, here most of the trainers, they will take Amazon EMR. Here they will configure. They will create EMR on the EMR. They will explain this is here. That's Amazon EMR already existing setup. On existing setup, explanation is not a big thing. Anyone can explain. No, I will set up everything on your laptop. On your laptop, how to set up your Hadoop here? Manually, step by step setup here. If you able to set up manually here, then easy to understand Hadoop here. Right again, yeah. Yeah, that's all for today. Yes, any doubts? Yes, guys, any doubts? Yes, any doubts? 1 second. 1 second. Just 1 second. Just wait for a minute. Wait for a minute.
Okay, sir.
Yeah, wait for a minute. Yeah. So duration, total duration. Yes, 50 to 60 days around. 50 to 60 days. This is only Hadoop, not including Spark and Scala. Spark and Scala, this is another 45 days. Spark and Scala, another 45 days. This is 45 days. 45 days should be taken care. Okay. Hadoop, 50 to 60 days. Maximum, I'll try to finish with 50 days only here. Yes, Monday to Saturday, everyday class. Okay, no break, nothing here. I will not take much leaves. Okay, no chance of taking leaves. Okay, Hadoop 50 days, Spark and Scala 45 days. Total 95 days. But the thing here, how at the middle of the Hadoop, yes, half of the Hadoop after finishing at the middle of the Hadoop, yes, we can start Spark and Scala. We can start Spark and Scala because that 50% of Hadoop knowledge means HDFS knowledge enough here. For to understand Spark and Scala here, yes, to understand is that HDFS knowledge enough. At the beginning, learning all the HDFS. That HDFS knowledge enough here. First 3 weeks, big data and HDFS, that knowledge enough for the Spark and Scala. So after finishing 3 weeks, you can start Spark and Scala parallelly also. Parallel, that time I will tell you, mostly same night hours only here. Yes, evening hours. Maybe 8 to 9:15 will be the Spark and Scala, 9:15, 10:30 Hadoop. Parallelly, after 3 weeks, I'll start Spark and Scala. Yes, if you done parallelly here, you can finish within 60 days. 60 days and a parallel. Yes, 60 days. Hadoop. Next Spark. In parallel, this is in parallel. Not now parallel here. Yes, after 3rd week, it's a parallel. Yes, after 3rd week, it's a parallel. Not now. After 3rd week, you can go with parallel here. Okay. Yes, Scala is like a Java. Scala is like a Java here. Okay, 1 second. If you know the Java and Python, it's a Scala. Scala is a combination of Java and Python. Okay. Scala is like a Java. No worry. Scala is like a Java. Okay. Next, one more thing. Spark. In Spark, there are some APIs here. Spark Core API is available. Next SQL API, next streaming API, streaming API. These you have to understand. Okay, they are very simple, easy to understand. Core API is not a little bit core API difficult here. SQL API is very simple. All the SQL commands. Streaming API, live data. Yes, these APIs very easy to understand. These APIs will be taking for 3 to 4 weeks. Yeah, 3 weeks enough. Next, Scala for 3 weeks. Scala 3 weeks. On these APIs are 3 weeks. So around 6 weeks, 45 days enough. Okay, 1 week maybe production, last week maybe production environment. Next, apart from the Kafka, I'm covering there. Kafka. I'm covering Kafka with Spark and Scala. Okay, next here I'm covering AWS EC2, next EMR, next RDS. These topics also covering Spark and Scala. So totally around 60 days maximum. Suppose if extending maximum 70 days, not more than. In parallel, you can do that. After finishing 3 weeks, you can start Spark and Scala parallelly. Because initially starting Scala, by the time of finishing Scala, Hadoop also finishing here. Okay, see, after 3 weeks starting Scala, first starting Scala here. So by the time of finishing Hadoop, so 50 days Hadoop finishing, by the time Scala will finish. From that, yes, 3 or 4 weeks. From that, after finishing Scala, 4 weeks enough here. 4 or 3 weeks enough to finish that. So after finishing 50 days of Hadoop here, 3 more weeks you have to spend. That's it here. Means 70 days. Around 70 days will be finishing here. Okay, right? Scala is not vast. It's very simple and easy. Scala is not a vast topic here. Very simple. Scala is very small one here. Most of the things depend on core API and SQL API and streaming API. Scala concepts are using very less. Mostly using core API and SQL API and streaming API. Scala is not a vast here. It's very simple and easy. Even compared to Python also very easy. Scala is very easy. Compared to Python, compared to Java, for all this, Scala is very easy. Okay, yes. So duration, this is okay. Next, Monday to Saturday. Yes, daily recordings will be provided. Yes, after finishing class, within 1 hour, you can see the recording. You can watch the recordings. I'll get Google Drive and upload you. Next, one more thing here. See my WhatsApp number. Take this my WhatsApp number. Ping your details. I'll create group for you guys. In group, every conversation here. If any doubts are there, ping me in group or ping me personally. I'll explain very clearly. 24/7 supports. Yes, except night 12 to morning 7. Except this time. Yes, next. Sometimes office meetings. Office meetings here. Except these hours. Except these 2 cases, other cases I can. Suppose sometimes taking classes that may not be possible here. Yes. So you can suppose if not responding, whenever I'm free, I'll respond immediately here. Don't worry. Yes, 24/7 support here. It's like a friendly interaction. Like a friendly interaction here. Okay. Yes, always giving support. 24/7 support here. Okay. Any kind of doubt I can explain because my experience is that here. I'm more than the Google. Any kind of doubts I can explain here. Java related, Linux related, Hadoop related, Python related, Spark related. This is my area of experience. Even embedded C also. Yes, I have a very good experience in embedded C. My starting career was embedded C. Recently also I worked on one embedded C project. Okay, this area I'm very comfortable. I'm an expert. Any kind of doubts you can ask me. No problem. Yes, see, after finishing this course, you can put up 5 to 6 years of experience, 4 to 5 years of experience here. Yes, you have to put up that much. I'll give this technology, not only technology here, experience. See, technology anyone will explain. That is not important. My experience. Yes, I'm giving my experience. So what are I worked projects here? All the real-time scenarios I'll be explaining you. Here, mainly considering my experience here. Okay. My experience is very, very important here. Right, okay. Technology is not an important here, experience. So technology, how to apply the technology in real time, that is important here. Okay, first learning technology, then applying technology, that's it here. Okay, all the real time scenarios will be taken care. Suppose simply if I'm explaining technology, I can finish within 1 month. 1 month is enough. Only technology means. No, it's not a technology here. I'm giving complete my experience. Okay. Yes, in total duration, half of the time will be taken only to give them my experience here. My real-time scenarios, all the real-time scenarios, every topic, real-time scenarios will be going to discuss here. That is my assurance, 100% my assurance here. Yes, minimum 4 to 5 years of experience you can put up. That is my assurance. Okay, next, one more thing you have to practice every day. If you able to practice, your practice converts into experience. Your practice only converts into experience. Without practicing, you can't get the experience. Yeah, that's all. Yes, my WhatsApp number 8179-189-123. Please note this WhatsApp number. Okay, send me your details. Share me your details. Yes, share me your details. I'll add to group. Yes, like what's a course? What's your name? What's your name? Next, what's a course you attending here? Course. Next, what's a time? Just you mention that and share me. Okay. Yes, your name, something here. Okay. Yes, maybe something like Sumit, your name. Yes, course. Hadoop. Hadoop. Yes, next time. Yes, 9:15 p.m. IST. Just mention this here. Yes, send me the details here. I'll add to group. Okay. Yes, every information shared in the group here. Okay. So what are doubts you have here? There. Simply can share it. Doubts. I can respond. Okay. It's an interactive one here. Yes, in group asking some doubts. Even others also can learn it. Group learning is a teamwork. Somewhat like a teamwork. Yes, more helpful for us. The group is more. Yes. 1 second. I'll show that groups. WhatsApp groups. My batches. Hadoop batches groups. See, WhatsApp groups. Yes, Linux 7 p.m. I'm taking care. Next Hadoop 8 p.m. batch I'm taking. Next your batch. Next one more Hadoop batch. Yes, 9 p.m. batch. One second. 9:15. Yeah, Hadoop 9:15 batch. This is, see, they are asking all the doubts. Yes, they are sharing screenshots also. Whenever they are checking here. Yeah, this batch currently running with this group information. Yeah, this 17 participants. Yeah, almost every batch will be with minimum 10 members, sometimes 20 members also. And this is in group communication. All these communication here. What are the communications? Their doubts asking, I'm responding here. All these communications. Okay. Yes, Spark and Scala batch also going on. One batch is going on. Spark and Scala. Yes, almost at the end. Completed batch also. Spark and Scala. This is 9 p.m. batch. Yes, previous just last Sunday completed. Recordings, 36 sessions completed. Yes, further 4 more sessions are the next Saturday, Sunday, finishing that batch. Around 40 sessions, Spark and Scala. This is Spark and Scala, all this. Okay. Next, when come to Hadoop or Hadoop's main number of sessions. Yes, around Yes, 50 sessions Hadoop also. Okay, Hadoop. See Hadoop. Yes, recordings. Yes, currently. Yes, 9:15. Yes, this AM batch. Yeah, this is 32 sessions completed, still going on the batch. Next, very old batch, previously old batch, 10 AM completed here. Recording C. Many sessions. Yes, 59 sessions are taken for them. 59 sessions. Yes, very long batch. Okay, long time taken care. Yes, almost 59 sessions, almost. Yes, without any holiday, even Saturday, Sundays are taken for that batch. Saturday, Sunday, every day taken. So 59 sessions almost for them. Okay. Yes. Yeah, that's all. Yes, just ping me your details. This is my WhatsApp number. Take my WhatsApp number. First of all, you take my WhatsApp number. Okay. Share me your details. I'll create the group. Yeah. So that's all for today. Let us find up session. Yes, tomorrow we'll continue. Right? Yes. Any doubts? No doubts. If no doubts, let us find up session for today. Right? Shall we wind up? Yeah. Thank you. See you tomorrow. Have a good